Hey, we're back, and we switched sides.
We did.
For no reason at all.
Yep, none at all.
Someone wanted to know where the stickers were on the back of my laptop.
This is
just not how I roll, but I'm giving you a gift. Me next to someone else's stickers.
And me on Scott Hanselman's laptop.
It's wonderful.
What damage can I do?
All right, cool. So we are going to talk about SignalR. Are you going to do this without slides, or are you going to even bother?
There's some slides. We'll do some slides to start with, and then we'll go from there. We'll go from there. So this is what we all came here to talk about, right?
The whole day
this is why I'm
culminated
here.
into this moment. Thank you for being
SignalR. So ASP.NET SignalR. This is our tagline, incredibly simple real-time web for .NET. Well, what does that mean? Well, let's have a little. So just to level set, remember where we are. We're here now, real-time communications with SignalR. We've got one more after this. We're going to have a look at, well, what can you do with SignalR? People ask what SignalR is a lot of the time. It's a fairly new concept in web development. We've been speaking, Scott and I, about this whole idea of the browser being a VM and having all these amazing subsystems that we can program against now. And one of those things that's kind of come to the fore in the last year is something called WebSockets. And WebSockets gives us the ability to have a real, persistent connection between my browser and your server. So rather than me just being able to pull stuff from you, you can now push it down to me. And that enables entirely new types of applications to be built, entirely new types of features. So what are we looking at here? Well, a chat application, sure, whenever anyone talks about real time, inevitably someone talks about chat, but that's kind of boring. We might write a chat application today, but we'll probably write some other stuff as well. A real-time hit counter. Is this like the counters we used to have, like 8 years ago?
Yeah. You have a little construction guy.
Yeah, a little spinny thing like a speedometer on the car. No. So, I mean, anything where, think about it this way. If you've written a web app today and you've ever seen a user of your app hit F5 to get new data, or you've used AJAX to pull down new data on some type of interval called polling, then SignalR is what you should be using to do that moving forward. So is SignalR WebSockets, or is it something more? Well, there's a little bit more to it than that. So SignalR sits on top of various mechanisms for doing real-time on the web. So WebSockets is one of those mechanisms, but if you don't have WebSockets, then you need to have something else, and we'll talk a little bit more about that later on. So it's an abstraction over the top of these transports. It is based on sort of evented signals, this idea of I'm sitting there waiting for stuff to happen with this persistent connection, and then when these events take place, hey, server, send me some data. It's event-driven and it's asynchronous. It gives you sort of the connection semantics that you need. So I want to know when Scott joins my app. I want to know when Scott goes away from my app. It's not just about requests anymore. It's like Scott is here and it's present. So I want to know when that happens, and I want to know when he disappears. I want to know if he goes away for a very short period of time and then reconnects. So we give you those base level semantics. We also give you the ability to kind of group a bunch of people into a logical thing that you can then broadcast to. And that leads on that last point there. We can either broadcast to everybody, we can broadcast to subgroups that we create, or you can just broadcast or send to a specific person or a specific device. So what does it do? So it creates this persistent connection over HTTP. It really does make it easy to build these types of multi-user real-time web applications, and you sort of program against the SignalR world. You don't have to worry about what's going on under the covers most of the time. Speaking to the black box that Scott talked about before, this is another one of those black boxes. And most of the time, the black box will do its job. But, of course, sometimes you'll have to lift the lid, and maybe we'll have one of those situations where we can have a look at what's going on underneath. But it'll auto-negotiate that transport for you. It'll try WebSockets, and if that doesn't work, it'll try some other stuff. So here's all the things that we're going to try for you in order to get one of these persistent connections set up between the browser and the server. So the WebSockets is our highest fidelity, lowest latency transport that we support today, and it's part of the HTML5 sort of umbrella of specifications. Moving down from WebSockets, we have something called server-sent events, otherwise known as event source. It's exposed as event source inside the browser in JavaScript, and that's supported by a whole bunch of browsers. Basically, every modern browser other than IE decided to support server-sent events. We have a technique, and not a standard, it's a technique called forever frames. This has been around forever, funnily enough. We've used this in IE for years, right? It's the way to create a hidden iframe in your page, have it request some document from your server that actually never finishes. All that document does is send down script tags forever. And the browser is kind enough to execute script tags as they arrive. And so if we just keep that request running forever, we can just keep sending down more script tags, and it looks like we have a persistent connection. So that's kind of cool. And if none of that works, we fall back to a technique called long polling. So what does Signaler do? Well, it allows that server-to-client push. It opens up HTTP beyond client getting stuff from the server and lets the server push stuff down to the client. We also have a nice API above that, which mimics an RPC, or remote procedure call type of thing, which we'll have a look at. We built it asynchronous from the ground up so that we can scale to many, many, many connections on a single box. And we actually use the async primitives and support inside ASP.NET. You saw some of those earlier today. You spoke about async. You saw how you could call out to different web services in parallel. That utilizes the server resources available to the best possible use so that we can get many, many connections. And then when one server isn't enough, we can scale out beyond that single server by plugging into a provider mechanism that we have in Signaler. So we call these message buses or scale-out buses, and we have support for Service Bus if you're on Windows Azure, SQL Server, and Redis. And Redis, for those who don't know, is an in-memory distributed database system which has sort of a pub-sub mechanism and fairly popular in certain sections of the community. And we are open source on GitHub. So like most of the work the ASP.NET team is doing these days, we are open source. You can look at the code. It's in Git. Some of our work's in Codeplex. This work is in GitHub. And we not only have the source available, but we actually develop in the open. So if you go up to GitHub, you'll actually see our issues are all logged there. Our milestones are defined there. We really don't have any secrets when it comes to how we develop Signaler, which is kind of cool. So let's have a quick look at a diagram that kind of explains the differences between web traffic that we may have been used to in the past to get new data and what Signaler does. So here's our typical sort of HTTP request diagram. We have a client browser, we have a server, and the client makes an HTTP GET to that server saying, hey, have you got some data? Well, if it wants to get data sometime soon after the data arrives, then we're going to have to keep making that call over and over and over again. And so which is what we call polling, right? We would use AJAX to simply poll against the server saying, hey, you got data, hey, you got data, hey, you got data. And while this works to an extent, you have to keep adjusting that polling interval down and down to a smaller number to sort of mimic real time. If you want to get anywhere close to real time, you have to be polling quite frequently. And of course, if we do that too much, then you may put your server under adverse load. So with the advent of the real-time web, this conversation takes place in a slightly different way. The browser says, hey, server, do you support real-time? And the server says, sure, I know how to do real-time. I'm a new server. And we go, great, let's party on. Let's do real-time. And so from that point on, we have a persistent connection, and the server can call the client, and the client can call the server, and we just keep going from there. All right, so let's build an app, because talking is one thing, but building an app while talking is a completely different thing. So let's create an absolutely empty web application. And from here, I'm going to install some packages in order to do this demo. So I'm going to install Signaler. Here it is. Let's install Signaler, accept the license terms. This pulls in a bunch of dependencies and a README file, very nicely telling me that in order for Signaler to work, I have to actually add some startup code. So I have to configure the Signaler route, essentially, to handle the Signaler traffic. So let me add a global.asax to my application, and let me paste in that application start that the README file allowed me, told me to do. I imported the routing there. You saw the control.
And if I had a web forms app or an MVC app, what would I do with my routes as it relates to Signaler?
So the routes, this map hubs call here is going to add an entry into the route table, the ASP.NET route table, in the order and the place that you called it. So if you're using MVC already, you would have an existing route. You would put this one before the MVC route generally, otherwise the MVC route will swallow up the Signaler traffic. So route ordering is very important. That doesn't change. You have to be very careful when using routing that you define the routes in the right order. So here we go. So that's going to do that. So let's go ahead and start adding an app. So I'm going to build a new folder. I'm going to say move shape. And inside this, I'm going to start with some server-side code. So I'm going to add something called a hub. I'm going to call it move shape hub. And I'm going to derive from a Signaler intrinsic, a Signaler base type called a hub. So a hub is akin to, it's kind of like a controller in the MVC world. In web forms, the sort of primitive that we use is a page. We build on top of pages. In MVC, we use controllers. And in Signaler, we use hubs. So I'm going to add a hub, and any public method I add to this hub is going to be callable by all the Signaler clients. So I'm going to call this on move shape. And I want move shape to take in a couple of parameters. I want to take in an X and Y. And then once someone has called move shape, I want to tell everyone else who's connected that someone who's currently connected move the shape around. So let's do that. I'm going to say clients.all. I'm going to say clients.others. So don't call the person who just called the method. Call everybody else. And I'm going to call shape moved on the client, passing in the X and the Y. Now that's my server-side code done. Now if we actually hover over shape move for a moment, what you'll see is that it's actually coming up as a dynamic expression. And that's because if I hover over others, it's coming up as dynamic. Now shape moved isn't defined in my application. It's simply some text that I've typed into the C# compiler. I told C# it was dynamic, so don't check it for me. But at runtime, it's actually going to take shape moved and try and plumb it through the signaler system to call something in the client.
So no matter what you type there, it's going to compile.
Correct. As long as it's well-formed C#, it has to look like an index accessor or a property setter or a method like it is in this case. So that's my server-side code. I'm just going to decorate my hub here in order to give it a nice name on the client. So I'm going to say hub name, and I'm going to call it move shape. So now this is how I'm going to refer to this hub from the client. Let's go and add the client-side code. Let's go and add an HTML file here. We'll call it index. And then I'm going to start dragging in a few dependencies that I need for the client. So in this case, I'm in a browser, so the client code I'm going to write is going to be JavaScript. And the way that Signaler exposes itself in the JavaScript world is via jQuery plugin. So I'm going to drag in jQuery, and I'm going to drag in the Signaler plugin underneath that. I'm also going to need jQuery UI for this, so let me go ahead and get that. Go back out to NuGet. I'm going to grab jQuery UI. Very good. Let's drag that in as well now. Okay, and I'm going to add one more script reference here, which is a bit of magic. We'll talk a little bit about in a minute, to Signaler/hubs. Now, you heard John and Scott talk earlier today about this idea that in the routing world, once you've used routing for a bit, you kind of understand that URLs don't map to things on disk. They map to places in your application, and then your code can handle those things. So in this case, Signaler/hubs doesn't exist. There's nothing called Signaler/hubs in here. But that call to map hubs inside my global ASX that you made set up a listener, set up a route for that route, and we'll for that URL, and we'll have a look at what that does in just a moment. So I'm going to go ahead and write my client code. So I'm using jQuery. So the first thing I'm going to do is add a body on load or a document on load handler, and then once that happens, I want to get a handle on that hub. So I'm going to say $.connection.moveShape. So moveShape was this string over here. I'd said that I would be able to refer to this in the client. So let's actually pin this over here vertically so we can kind of see the server-side code just a little bit while I'm writing the client-side code. So remember, we have something called moveShape, and there's a method on it called moveShape. So let's go ahead and also add a handle to a DOM element that I'm actually going to move around. There's going to be sort of the object of attention here for this demonstration. So I'm going to grab a DOM element that has an ID of name. Now I have to go and define that method. So while I didn't define that method in C#, shape move obviously doesn't exist in C# as we said. It's going to exist on the client. So let's add that. We'll say hub.client.shapeMoved. I'm going to make that equal to a function that takes an X and a Y parameter. And then when I get a call to shape moved from the server, I need to actually move that shape around on the screen. So I'm going to do that just using jQuery, shape.css. And then inside here, I'm going to pass in an object to say left should be set to X and top should be set to Y. So that's using standard CSS positioning to move something around on the screen. So now that I've wired up my client side, I need to actually start the connection, start this real-time connection, this Signaler connection, and then once it's finished starting, wire up this client-side interaction so the person can actually move the thing around. So I'm going to say $.connection.hub.start. So what that does, $.connection is the jQuery signaler plugin. Off that, we have a hub property which represents the instance, the actual signaler connection that all hub traffic is going to go over. So I want to go ahead and start that. And then when that's done, I'm going to pass in a lambda to done so that gets executed because start is an asynchronous method. When that's done, now the connection is running, I'm free to sort of let the user send stuff to the server because the connection is up. So let's go ahead and do that. So what I want them to be able to do is drag the thing around the screen. So let's say shape.draggable, that's a jQuery UI widget, lets people move things around on the screen. And I'm going to tell that when the drag event takes place on this widget, I'd like you to go ahead and run this function whenever anybody drags something around. And what am I going to do when someone drags something around? I'm going to tell the server that they dragged it around. So that's what my moveShape function is for. So let's go ahead and say hub.server.moveShape.
Why does it pop up a little error, like a little warning?
So what Scott's asking there is like, why is that there? What's this little thing?
Like
so that,
it doesn't look good.
No, so what that is it actually tells you there, the IntelliSense engine was unable to determine an accurate completion list for this expression. So it doesn't know that there is a server property on the hub. And the reason is that gets added at runtime by this JavaScript.
So it's the same. It's the same thing that we see on the server side, where you were saying .move shapes. The compiler has no way of knowing
Correct.
that that's going on. So on the client side, the compiler, in quotes,
Yep.
is trying to kind of glean what's going on. So
Absolutely.
theoretically, you could fake it out.
Yep.
You could, let me ask you this,
Yep.
and this is, forgive my ignorance, you could probably run the app, visit /server/hubs, save that file,
Yes.
then put it in.
We even have a utility to do that for you.
You're kidding.
We can show that later.
Okay,
on, maybe.
cool.
Yeah. So what we'll see is when we start running this app, I'll actually show you how this magic thing works. Because when you just look at this code, you can kind of go, well, how does this all work? JavaScript doesn't have methods missing, right? The methods have to be there at runtime for this to work. So let me call my moveShape, and we know that I have to pass into moveShape X and Y, because that's what the server is telling me. So let's go ahead and get X and Y off this. This is just a DOM element, so I'm going to say this.offset left, and I'm going to say this.offset top or 0, because that can sometimes be null. Okay, so that's fine. So there's my JavaScript code written. So let's go ahead and actually add the DOM element that I want people to be able to move around. So let's put that in here. It's going to be a div with ID equals shape. And let me make it look like a shape. I'll add some style. I'll say shape. It's waking up. There it is. And inside that, let's give it a width and a height. So we'll say width 100 pixels.
So you're giving that block element a little room to move.
That's exactly right. We'll give it a background color. Otherwise, a div takes its rendering from its contents. So if I don't tell it anything else, it'll just be nothing. And I want a nice color, so let me use this awesome picker here. I like this blue over here, and I'm going to say cursor equals move, because there is actually a nice cursor built into CSS to indicate something's movable. So let's do that. That's built. Let's run that up now. Okay, so there's my shape on the screen. That's good. So far, so good. Let's open up a different browser, because real-time demos of collaborative applications, I think, always work better when there's more than one user. So let's pick this thing up, and you can see now it's moving on the other screen. If I go over to this one, I pick it up, it's moving on the other screen. So with very, very little code, what was it, one line of server code, a method with one line inside of it, and then some client-side code, I've now got these two browsers talking to each other.
And what do we see underneath? Is there a way to see the traffic?
So
do I need Fiddler, or what do I need to do?
Well,
to see
it depends on the browser you're using. So let's have a look at what's actually going in under the hood right now. So I'm going to open up the dev tools in each one. Let's go over here to the network tab in IE and start capturing, and we'll do an F5. Okay, so there's a bit of stuff going on. So what you'll note is that down here at the bottom of IE, we get this negotiate request. So when I call .start, the signaler client says, right, I need to negotiate with the server. I need to figure out what transport am I going to use to connect. And if we drill into this, what we'll see is in the response body, what we'll get back is some JSON. And we've looked at a lot of JSON today, but if I scroll along here, we get a whole bunch of interesting information. Here's a unique connection ID that represents me, and then this is flag, try WebSockets equals true. So what you can see is the server has said, hey, I can do WebSockets. So how about you go ahead and do the next connection as WebSockets. Now this is unfortunately where the IE10 network tools stop working. So the IE10 network tools don't show WebSockets.
Okay. But there was a handshake.
There was a handshake.
It stepped to the side, and we can't see it now.
Right. So we don't even get to see the handshake.
So we would need Fiddler to see that if we had IE.
Correct. But in Chrome over here, where they have a slightly newer dev tools, you can see down here that after that negotiation request, there it is, there was a connect request.
I see status. I'm familiar with a lot of different codes, right? We all know, 301, 304, 101.
Switching protocols. So this is a status that was introduced to support WebSockets. It's basically a way for a server and a client to agree to elevate from the known HTTP standard that they were working with to something beyond HTTP. So when you think about it, WebSockets in essence is really a way to establish a real socket using HTTP. Once you've done the original HTTP, there's no HTTP anymore. It's just a binary socket. And so that's essentially what this is. This is a handshake saying, hey, I'd like to do WebSockets, and the server returns 101, sure, let's do WebSockets. And then Chrome even goes further, so I can drill into this WebSocket, and note this tab over here. It actually has this frames tab. And so you can see at the moment there's a bunch of empty JSON payloads because we do keep alive. We send pings between them to ensure that idle connections won't get disconnected, because a lot of...
Is that expensive? Is this going to
That's
cost
quite
me?
literally 2 bytes of information. So because it's an open and a close. So if I actually go around and start moving some stuff around now, and I go here and I refresh, it's not real time unfortunately, you can see the frames now. So here are all the individual socket packet frames that went over that Signaler was sending to represent the method calls that we were making between server and client. So I can tell you here, this is basically telling the server, look for a hub called moveShape. So hub is moveShape. Look for a method called moveShape.
Nicely packed.
Right, nicely packed. We did a lot of optimization before 1.0. And then a whole bunch of other stuff that, the arguments. So here's A for arguments. There's that X and Y.
Right.
And then the I is a representation of the unique sort of invocation.
So if accidentally, for some reason,
Yep.
they came out of order,
Yes.
you can put them back in order.
So basically, we guarantee message ordering for you, and we can detect when the underlying connection goes away. We can reconnect and say, pick up where I left off, because here's the token that represents where I got to last time. So that's all good for WebSockets, but what about other types of transports? I said that that we do other things. So IE has this nice feature that lets us roll back in time, and I can switch back to the day when we didn't have WebSockets. So I can pretend to be IE9. And if we look down after the negotiate request now, we have transport equals forever frame.
So when you pretend to be i9, it's not just the renderer.
Correct.
You really are pretending to have functionality.
Yeah,
that is
the
i9.
APIs all change as well.
Interesting.
And so the code that we write in our client to say, hey, is WebSockets available, that feature detection that we spoke about before, that kicks in and says, well, no, because it's not there. The method doesn't exist. And so we try and connect with forever frame instead. And you'll note how very different these two types of requests are. So you see this one is just sitting in a pending state, whereas over here in the WebSockets world, this thing is done. Like it happened, and then we're just parting on a socket from that point on. This request cheats. So as I move this one around now, that request just continues to sit there in a pending state forever. Now, if I move from the left, what you'll see is a lot of AJAX requests get sent up. So forever frame is a technique only for getting data from the server to the client. If the client wants to send to the server, it has to do a standard AJAX post.
I see. So on the left, when you move it, it's going and sending it like that.
Correct. Very, very quickly.
Very small, but it's going.
Very small, but doing
And on the right, it's basically got a phone line open.
That's right.
And it's breathing on the phone line.
Absolutely.
And it's just not going to hang up.
That's right. And it's basically the difference between a full duplex channel and a half duplex channel. The one on the left-hand side has to have 2 channels to simulate full duplex, because it only go in one direction on each.
And is this going to work in different proxies? Am I going to have situations where I'm behind some proxies and things won't work?
So that's one of the other reasons why fallback is really important. So even if the client and the server both support WebSockets, maybe one of the 37 devices in between you doesn't. And for whatever reason, it gets in the way and sort of gets all angry, as you would say, on the connection. It says, hey, I don't know what this 101 means. I'm just going to kill it. And in that case, we'll detect that error and we'll fall back to a lower transport so that at least the browser can continue to work. And of course, all this is happening inside the black box. Your application doesn't need to worry about it. You simply write the code that we saw before, and all this just continues to work, which is really kind of cool. So this is great. This is a browser client. So I've obviously written a browser application. I've got different transports. I've got fallback. That's pretty cool. But if it was just a browser, I mean, it would be cool. But as we've just spent the last hour before this one talking about, it's not just about browsers now. It's about lots of different types of devices. We have mobile devices running apps, and we have desktops as well running apps. So what about supporting other clients? So we do. We support more than JavaScript. We also support .NET. So I'm going to switch over to a different version of moveShape here. This is a more complete version. It's been extended to support not just a web client, but also a desktop client. So this is using WPF. If I look inside my main window.xaml, you can see the design is going to load up. I have a bunch of stuff here. There's my blue shape that I'm going to move around the screen. And if we go to the code behind for this, we'll see a slightly different API, but it does look very, very similar. So in this case, I'm on my Go method. I'm saying, OK, create me a hub connection, and then create me a proxy. So we didn't see this in the JavaScript world because that was taken care of by that special magic link that we talked about.
Then including Signaler hubs, dynamically generated JavaScript to give you a proxy effectively.
That is absolutely
that
correct.
Same proxy that IntelliSense couldn't see.
That's exactly it, because it only exists at runtime. And for full, this API here actually does exist in JavaScript. In fact, I can prove that. I can go back to here if we run this app again, and we actually look at what was sent back by that request. So here it is. Here's the signaler/hubs. Let's look at the response body. Let's copy that out and go into Notepad and paste that in. So if I come down in here, we should be able to find a proxy call.
Spell it right.
And if I spell it right, I'll do an even better job being able to find it. Oop.
At the bottom.
Yes, now I've gone to the bottom. So here we go. This.create hub proxy move shape. So that's very similar to the .NET code we just saw. And you can see what we're doing is just creating you an actual property on something called move shape. Here we are defining that client and that server property I was interacting with. And here's the move shape function I was calling on the server.
So that move shape function is the, on this function, you're saying on move shape, do this stuff.
Actually, this is the other one. This is the server one. So this is the one that I call on the server. So if I was to add foo on that method, it would show up on that class. It would show up underneath here.
I see.
And if you look at the method body, you'll actually see all it's doing is saying, look at the move shape proxy, call its invoke method, and then using JavaScript we call apply. Let's invoke this function called invoke. A little bit confusing. We have a function called invoke, which we're going to invoke. And we're going to pass in the move shape proxy, and we're going to merge a bunch of parameters together to make the parameters.
And that's where you take a first-class API and turn it into a second-class API.
Exactly.
Because nobody wants to go and invoke stuff.
Exactly. But sometimes you have to. You have to do things like that are late bound.
Exactly.
Maybe you don't know the method name until someone types something in. And that way, we do have that. You can call invoke and pass in a string, which will be the name of the method to call. And if we go back to the .NET code, that's exactly what you're going to see. So here I go. I create a proxy based on a string. Here's where I would wire up my client-side method. So hub.on represents I have a method called shapeMoved. That is, the client has a method called shapeMoved that the server wants to call. And then down here, we can see where I am calling a method on the server via hub.invoke called moveShape, and I'm passing in some parameters. So this is like RPC by telephone. Like I can't do it directly, but I can give you enough information just by talking down the line for you to call that method on the server or call that method on the client. So it's still strongly typed. This is .NET. This is a generic method, so I can accept strongly typed parameters and deal with them here. So this is WPF code. I've got a bit of dispatcher.invoke because as we said, Signaler is async. All of this stuff from the server is coming in on a different thread, so we have to push it back to the UI thread.
Does this replace something? You use the term RPC. We've always been, there's been RPC for years and years and years.
Right.
How should I put my head around this? Where does Signaler fit into other communication techniques that I might potentially use? I'm sure there are people who have made, for lack of a better word, poor man's RPC with other techniques, either on their own, rolling it completely, perhaps on top of COM or on top of .NET remoting in the olden days, or on top of SOAP. Where does Signaler fit into the services kind of offering?
Right, so Signaler really shines when you're using it in a situation where you need to call to an endpoint that can't expose itself. Right? So a server is on the internet. You can just post stuff to the endpoint that it exposes. A browser isn't. A mobile phone isn't. I can't just post to
I don't have it open. I can't open the firewall on my phone and have you call me.
But you can call out and then keep that connection open so that I can call you back. And so if that's the situation, Signaler is a really good fit. Because once you've established that connection, you can invoke methods on me over that connection, and I can invoke methods on you. Now, if all you ever do is accept calls from your clients, then Signaler isn't going to really do much for you. If you want to be able to push back to your clients, but you also have a callback situation, maybe Signaler is all you need. If all you need to support is Signaler clients. Remember, we have a client. You can't just call us via standard HTTP. You saw the protocol here. You have to understand all that funny JSON that we're sending back and forth.
Now, I've got a tiny Signaler hub that I've got where I have a little WPF app and some arrows, and I move a camera.
Right.
So I've got WPF to WPF, and the reason that I did it is that I didn't want to VPN into the same network.
Right.
But someone said that I made kind of a, and again to use the term poor man's, kind of an AirSats service bus.
Yes.
You know what I mean? But it's extremely rudimentary.
We call that like poor man's relay.
Poor man's relay.
That's all it's doing. You have a tiny Signaler app in the cloud with one method, and all it does is let two people from behind two firewalls connect to it, and then talk to each other, relay via that one method.
When would I know that I'm using Signaler in a really great way versus, oh, I've outgrown it, it's time to go get an actual service bus or an actual relay?
That's a really good point. So, I mean, Signaler is not durable. That's like the one thing that you're going to find. If you want durable connections and durable message delivery, We're not that.
Durable is the computer science word for it, it's important.
It's important. If I send you a message, I need to make sure that you get it.
Yeah.
Like reliable and durable. We are a socket. Think of us as a TCP socket. Is it up? It might be this second. Is it up now? Yeah, no, it went down. Oh, now it's back up again. That's the API we're trying to mimic. And so you shouldn't be looking to, even though we try these reconnect semantics, we do our best to keep a logical connection open, and we do our best to give you the messages that you'd lost in that window. But that window is very small. Like the window that we support for buffering of messages during reconnect is like 30 seconds. Now, it is configurable, but we store those things in memory. So you really don't want to be storing lots and lots of messages in memory in order to do that. That's what durable messaging is for. So something like Service Bus, you post a message to Service Bus, it writes it to durable storage, to disk. And then only after that's happened, it would deliver it to the people subscribing. So different tools for different jobs.
Right.
But using something like Service Bus and Signaler together is absolutely something that we encourage. So I've seen demonstrations of apps where Signaler provides the real-timeness, so I can get stuff to you via Signaler much quicker than I can via Service Bus because the durable write takes time. We're talking milliseconds, but it still takes time.
Right.
And then once that durable write has happened, I can refresh the data on your screen in real time with the stuff that was actually written to disk. So in the meantime, we call it like the wet ink and the dry ink principle, which is kind of cool things you can do. So let's switch back here and look at the difference here. So now I've got a web client and a desktop client. I'm going to Control F5 here to start it. We note that we actually started 2 applications. Now I added an extra little bit of API in this application, which is a counter showing how many people are connected. So I can now pick up the thing over here, and it draws no matter which. Left-hand side is WPF, to be very clear again.
Could you open up another browser? Pretend it's another machine?
Yeah, let's do it. So let's come back here.
Open up Chrome, maybe?
Let's go down here. Let's open up Chrome.
And Firefox, too, say. I mean, you've got 3 browsers.
Yeah, let's do it. Firefox. Okay, so now I've got 4. 1, 2, 3, 4. 3 browsers in the WPF, and I can move them around. Let's.
There you go. Resize it for the full effect.
Look at that. Pretty cool. And so that tells you that we're also giving you ways to figure out how many people are currently in there. And in this demo, I've actually done the work to do relative movement. So you can see they all get to the top corner, but as I move, some move more than others because it's a relative position. I just did a bit of math in that demo there, which is kind of fun. So as I close them now, see that they go down as well. We give you events when people disappear. So those events are pretty straightforward. Let's have a look at what they look like. So here I've subscribed to another method. It's called client count change. So this is in the client. This is my WPF client. So the server is invoking a method called client count changed whenever someone disappears. So let's look at the server-side code. Let's come over to move shape. Look at my hub. This is my move shape hub we saw before. But now it has a couple more methods. It has a connect method, a reconnect method, and a disconnect method. And what that means is we'll call the connect method on your hub whenever a new connection shows up. So now you can track connections. And we'll also call disconnect, obviously, when people go away. So we will flow through any credentials that appear from the request. We'll give those to you. You can get to those via context. And we'll also raise events when people come and go. So now you have all the data you need to track, map Scott is currently on connection 1, 2, 3, 4. Damien is on connection 4, 5, 6, 7. So if Scott wants to send a message to Damien, I need to look up Scott's connection from my application state. So you would generally put that in your database. Look up that connection and then send a message to that connection ID.
Now, these tiny little bits of information, you said in one case that there was as little as 2 bytes moving around. Am I hitting one machine? Or if I have a farm, am I bouncing around?
That's a great question. So let's flip back to the slides and we'll start talking a little bit more about some of the some of the scale-out stuff when we get to the scale-out. So here's a very simple example of a chat application. We saw Move Hub. A lot of people talk about chat when they talk about Signaler. So there's JavaScript, hub connection.chat. I have an add message, and I go ahead and start, and then I can send messages to the server. Very, very similar to what we saw, except this time I'm updating an LI instead of moving a shape around on the screen. And then with .NET, same API, just expressed in .NET sort of idioms, and then I can now get clients for .NET WPF, Windows Phone 8 we support, and Silverlight 5. So the other thing to note before we move on is Signaler is part of the family. It is an ASP.NET thing. You can call support. We released 1.0 on Monday, so it sort of slots in here underneath services. So as we spoke about before, you may have web APIs because you want to support different types of devices using HTTP to get data from your server and to post data to your server. But if you want to send real-time updates, Signaler is really the thing to be using for that.
So we talked a little bit about this during the web API talk, but in a larger context, because we've got enterprise developers and people who are listening, you've got WCF, WS Star,
Yep.
big, secure, enterprise, durable. They follow all of the rules that one needs to follow. I usually put it in the context of when you're moving money,
Right.
you're probably going to move that money with WCF. Then you've got your web APIs, JSON type stuff, and then SignalR. So when you need real time, when you need eventing, but I could use them all, couldn't I?
They're not mutually exclusive at all. You can totally use them all together if you need to.
So I could have let me just brainstorm. I could have a stock trading application.
Yep.
I filled up my positions with JSON using Web API.
Yep.
That, from the server side, made a call using WCF to some backend with some certificates.
Yep.
But when the trade finally went through, I was notified via SignalR.
Absolutely. And the critical thing is there that SignalR wasn't used for the actual trade operation. It's not made for that durable, sort of really high important thing. It's used to layer on the real-time aesthetic onto your application, right? To enable that type of real-time update that you couldn't have done just using polling.
Right. I always give the example of Expedia.com.
Right.
For years, you go into a website and you put in your flights, and you hit search for flights, and it goes beep boop, pop boop, beep boop, and you're like, wow, that's amazing. It's real time.
Yeah.
It's really just an animated GIF. And back in the days when Internet Explorer would click, every time you would navigate, you'd go click, 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 because somebody's pushing F5 for you.
Absolutely, absolutely. So I've shown you a move shape, which was kind of a bit of a Mickey Mouse little sample, and we saw a chat sample there, but you can actually build very different types of applications with this too. Now that we have a real-time connection, we can use that to build completely new types of experiences. And one of those things is real-time gaming. So I'm going to go to a website here. This is something that was built by one of the people on the SignalR team. This is shooter.signalr.net, and as you can see, it's a real-time fly around in the world shooting application.
Can we all go in there now?
Yeah, absolutely.
Can everyone go up
there?
there?
I just leveled up and I picked up, there's a guest there, someone's joining.
So everyone who is on the internet right now.
And so, this has some pretty interesting gaming mechanics as well.
How do I know
you
it's
guessed
me?
119?
No, I'm Chancelman.
Oh, you're Chancelman? Okay, well, I need to find you. And so this has some pretty interesting game mechanics. So
I'm green.
All the mechanics of the game are controlled on the server. There is no authoritative logic on the client, so you can't cheat this system. So when I shoot across like this, and I hold down the spacebar to shoot lots of bullets, you'll see I get lots of bullets, and then it stops, because the bullets are rate limited on the server. And then when I let go, they'll recharge on the server side, and then I can fly in and kind of do a big splay of bullets to take someone out as well.
Is there a way for me to see how many people are here?
Yeah, so it actually says, I don't think there's enough information, I think there's enough space on the screen right now. If I zoom out a bit, there we go, I can see that currently in the world that there are 10 people. And I just got blown away on live TV.
So world targets.
World targets is the number of things that you can blow up. It's just gone up to 14. So it's someone called Sean just arrived, and I'm going to try and...
If you don't mind, can I just tell the people?
Yeah, go for it. Shooter.signalr.net. So here's a few other people coming in right now.
Okay. Let's see how fast it is. So I just tweeted that.
Yeah.
Let's see.
See how fast we can bring it down. So I try to remember what size VM we have it's hosted on right now. We'll see how long it can go before we just basically use up all the resources on the server.
Well, hope you don't mind.
No, absolutely. This is what it's there for. So the code for
world
this
targets
game,
is now 90, 97.
Whoa, gee, that went up very quick.
101, 102.
It's handling it very well. So you can double tap to do that a little hyperdrive.
This is on an Azure VM somewhere?
This is on an Azure VM up in the cloud.
120.
It's on Windows Server 2012, so it supports WebSockets. So we're all using WebSockets right now. Little tip, if you have IE10, use IE10. The IE10 Canvas engine is vastly superior, I have found, just personally, to rendering this than the Chrome engine the last time I used it.
So 150 people.
We've got 150 people on here right now, and it's looking like it's handling it without much problem at all.
Should we just play this for the rest of the day?
Yeah, I mean, we've got 11 minutes. Why don't we just sit
So
here and
as
play
you
this?
see, after I tweeted it, people showed right up.
Yeah.
And they were able to get this working.
164. So the code for this is available. If you come down to the little I down here, you can see the code. There's a link there to GitHub where the code is. It's written by a guy called Taylor Mullen on our team. And the design was done by the fantastic Azure design crew who do all the design work for the portal as well. So it's a great little game. It takes pull requests. We'd love to see new features that come in as well. It supports leveling, supports all types of wonderful stuff, and importantly, all the real-time stuff is done with SignalR. So
you can learn all about how this works.
You can absolutely learn about how this works, look at the game loop he's using, how he's doing the physics calculations, all that type of stuff. Pretty smart guy.
230, we're topping out here.
We are. We're doing pretty well here. It seems to be handling a little bit of stuttering, but it seems to be going pretty well.
What is the stuttering? Are you telling is SignalR telling the world where everyone is at all times?
Yeah, so what happens is there's a couple of loops running on both the client and the server. So this is a typical real-time gaming architecture. What I have is on the client, I have a loop that's running at about 5 hertz, that's 5 times a second, that's reading the status of input.
Which seems like a lot, but kind of for something like this is very reasonable.
Right, so 5 times a second, we're going, what keys are down? Oh, the up key is down. Oh, the space bar is down. And then we update client-side model to represent that. And then at a different cadence, usually a slightly lower cadence, we push the current state of the model to the server. We say, okay, currently, I have the up key and the left key down, so that the server knows what I'm trying to do.
I think we just crashed it.
And then on the server side, what happens, very good. No, it's still there.
No,
and on the server side, what happens
250.
Is all that state information is coming in at a given rate. We update the in-memory state based on when it comes in from the client. And then we have a physics loop that runs on the server that does all the calculations based on these commands coming in from the server and updates the authoritative game state. Like, where is Damien right now? Where is every bullet in the system? Did a bullet just collide with a player? And then we have a fourth loop, there's the second loop on the server, that is broadcasting this state down to all clients. So this is a pretty standard real-time web gaming architecture. There's a lot of articles about how to write these types of games. And so what the stuttering generally is what happens is if your machine gets any type of lag at all, you'll pause for a second and you'll get a bunch of data. So you can still fly around, and the client-side logic will predict where it thinks things will be, but when it gets the updated information, it'll very quickly correct itself back to where it actually is, because the server's authoritative.
So arguably, the farther away you are, the less we care about what you're doing.
And people who have played Quake or something, on slow connections will know the experience of, hey, I shot you, and then 3 seconds later you realize, no, you didn't, and they run around.
Just a little product idea for you.
Yeah.
I think that you should have a banner in the upper corner, like one of those fork me on GitHub type thing.
Yes.
And just say, do you want to write games like this? And send them off to the code. Because right now I'm looking at this, 250 people just came in, but they don't know what this is or how they can write this code. We should tell them that.
Yeah, so it is there, it's just hidden. As I said, you have to click the I down here.
Yeah, that's too hard.
And it is down here underneath here. That's a good idea. We should just make it front
put it in
and
their
center.
face.
Yeah.
Some kind of a banner. That's fantastic.
So that's pretty cool.
I love that. Okay.
Lots of people in here right now. I could just play it all
250.
day. Fantastic.
Looks good.
So these are the types of experiences that you can build with SignalR. So you asked a question about scale. So we're hosting this on a VM. We just handled 200 people coming in and blasting around with, there's 400 bullets currently running through the system
and 200,
as well.
200 real-time people is different than 200 page views.
Absolutely. So there were 5 bots in there. There were some people called CPU, but the other 195 people were actually real
I was
people.
wondering who they were.
Yeah. So when it comes to scale, there may get a time where one server isn't enough, or you simply have more than one server because, hey, you want fault tolerance. If that server goes down, you want your app to keep
So that
going.
whole thing's on one machine?
That whole thing is on one machine. And typically with real-time gaming, you connect to a server because the state is held in memory. You can't persist this out to a database in real time. It's just not fast enough. So you'll be aware of this idea of lobbying. So you come in, if it were a real-time game, everyone kind of sits in the lobby and agrees about who's going to go into what game. And then the game starts and you all play the game for a period of time. You're generally connected to one server at that point. If the server goes down, your game dies.
So that's interesting. Is that why some of these real-time gaming things, they segment their world?
They shard their worlds. Exactly.
Canada's on this machine.
Absolutely, that's right. And so, you could think with a lot of engineering, you could do something like when I get to the edge of a world, you could go through some type of hyperdrive transition, and then now I'm on a different server. And what happens is, the software is actually telling your computer to redirect to a different machine and pick up the game there. So there's lots of techniques you can use to sort of scale out something like real-time gaming, but for real-time scenarios that aren't that demanding, for ones where it's just you pushing stock updates or you doing chat, something more like Jabber. So we have another example of an app up running in Azure called Jabber. So we can see it here. This was written by David Fowler, the co-creator of SignalR, along with me. And I can go in here and log in as me. Actually, I'll log in as Twitter. What am I doing?
If you log in as Twitter, you'll be logging in as me.
Oh, awesome, even better. So here I am logged in as Hanselman on Jabber.
Oh, no.
And so this is a chat application, very similar to IRC back in the old days, but it is a web application running in Azure. It's a cloud service. Shooter was on a VM. This is actually a cloud service. And it's written using a whole bunch of cool .NET things. It's Signaler, it's Web API, it's Nancy, which is an open source .NET micro web framework, entity framework, and a bunch of other things for doing things like compression and things like that. And so you can come in here, you can create rooms, you can sort of flip around and see what's going on.
And the source for this is available as well.
And this is on GitHub as well. And so you can even see down the bottom right-hand corner here, he's got continuous deployment set up. So you can see that this was deployed from this Git commit, that's a SHA from Git, on the master branch at this time. So I can click on that, and it'll take me straight off to GitHub and show me the commit that made this actually happen.
Very cool.
So some pretty cool stuff there. So if you want an example of a really rich chat application built with Signaler, Jabber is definitely the one that you want to look at.
From my perspective, if people look at how can I make an entire app with Signaler, they're missing the point.
Right.
I think that if I'm watching this right now, I'm going to think about, maybe I'll take my blog like Hanselman.com,
right,
and I'll add like how many people are online, and maybe I can talk to them.
Yes.
Or a real-time notification of like secure inboxes.
Yeah. Absolutely.
So just additions to make the experience more rich.
One of my favorite examples is a lot of people might be line of business developers. They have an enterprise application with text boxes over data, as we used to say. But a lot of these applications have to deal with concurrency. What if you and I log in and edit the same record at the same time? And I've certainly worked in companies where I need to be able to know that you edited this field and then I edited this field, auditability. Well, you have to deal with conflict resolution, because maybe I make a change, and while I'm in the web browser, you come in and make a change and save it before I got a chance to save mine. Well, I can't just override your change, because maybe your change has context that I need to take into consideration with my change. And so imagine what happens today. You use something like optimistic concurrency with the database, which means that when I try and save, it fails. It says, nope, Scott beat you to it. You have to try again. You can use pessimistic concurrency, which means I want to edit this record. While I'm editing it, no one else is allowed to. So this is the idea of taking a lock and saying, if Scott tries to edit this record while I'm editing it, he can't. He has to wait. And then there's the idea of no concurrency. Well, last person wins. Whoever gets in there can edit. But in the situation where the edit fails, you need to somehow resolve the conflict. So you could show some sort of dialogue that says, hey, you wanted to save this change, but Scott saved this change since you started looking at it. Do you want to try and merge them together? Do you want to take his change instead of yours? Wouldn't it be great if you could do that in real time while I'm still in the form? So imagine I'm editing first name of a customer, you come in and change it, and then save it. A little thing could come up on the screen next to first name, like a validation, saying, hey, letting you know this field has changed. Click here to resolve the conflict. It flies out in the field for you. You go, oh yeah, Scott just changed it. I'll click that, and I continue on my way.
It could, totally brainstorming. It could even say, and he's online right now.
Do you want to talk to him about it?
Talk to him, you guys can work it out.
Right, and so you can see it really does enable completely new experiences that you just couldn't have done without this type of capability before. So even if you're writing text boxes over data, there are absolute possibilities for using Signaler in the application that you have today. It is not just about chat, and it's not just about gaming.
What about using Signaler as a client-side JavaScript message bus? I mean, there are other ones like that. Not Signaler for real time, but for having everything run through Signaler. If I were doing verification, validation messages, and data's being updated, could I plug Knockout and Signaler together?
That's a fantastic point. We're actually thinking about some of these things right now. Let me show you some in the last 2 minutes here. Why not? Let's go look at some of the ideas I have for the next version of Signaler. We just shipped 1.0.
So this is just you goofing around?
This is me goofing around. I'm going up to gist on github.com, and this is how I write specs. Because I'm a terrible program manager at Microsoft. I hate writing Word documents.
Yeah, you never write Word
So I write code. And so here is my idea. So I wrote my spec as a gist.
Why don't you Control plus?
Yep, we'll zoom in a bit so people can see this, right? So here it is.
So this is not anything that works. This is just how you wish it would work.
This is absolutely right. Let me just make sure I've got the right one, because I had a few iterations of this idea. This is the right one. Okay, so let's have a look what we have here. So we have some UI up the top. Here's my chat UI. It's a standard form and a UL for holding the messages that people are sending to this chat room. And it's got some data binding expressions in here for knockout. So when I raise the submit event on the form by clicking on the submit button, I'm going to call send message on my view model. Standard knockout, we saw some examples of this before. We can see that my UL is being data bound to the messages property inside my view model.
So far everything here is possible.
Everything so far here, nothing is new.
Now you're referencing a version of SignalR that doesn't exist.
That doesn't exist. 1.5.
It's on Signal
the
1.0,
mythical 1.5.
right?
This
It's
is
a clever way to write a spec.
Thank you.
No one can copy paste this.
And have it work.
Because none of these versions exist.
And so then down here is my knockout view model. So this, I'm using the prototype pattern here. So I have a constructor function and a prototype object that the constructor inherits from, essentially. So inside my constructor, I have my new message and my messages, which are just types of KO observable. So this is model view model. So when this thing changes, anything bound to this is going to update in my UI. And then I have a function on my prototype, which is, hey, go ahead and send this message. But note, send message isn't doing anything over the wire. It's not doing AJAX. There's no SignalR here. I'm just saying, go to the messages array, which is an observable array on my function, on my model, and call push. That's a JavaScript array method for adding stuff to an array. So add the value of new message is bound.
So it throws it into the array, and the only people that are who's watching the array.
Absolutely. So the UI, so this function, this app right here so far would be me chatting to myself. This would totally work. Just me typing stuff in. It would add it to the UL.
So this is all possible so far.
This is all possible so far.
Having not yet scrolled down.
Having not yet scrolled down. So then we scroll down a bit further. This is all still possible to there. So what we do now is we create a hub connection using the other API that I didn't show you, it's like the .NET API for hubs. I create a hub connection and then I create a proxy for a hub that I call chat. There's no chat class, but I'm saying create me a proxy as if there was a chat class on the server so that clients can agree upon this thing. And then I go in, and this is where the magic really happens. Imagine that we have added some future additions to SignalR that let you work with client-side frameworks like Knockout. So I say $.signalr.ko or knockout.sync model.
Doesn't exist.
Doesn't exist, but you can kind of get the idea where I'm going now.
Yep.
Pass in the constructor function to your sync model, pass in your hub proxy, and we give you back the view model that you'll actually use to apply bindings. And what will happen now is that any page that visits this page, any browser that visits this page, if I add a message to here, it adds it to the messages property on the view model of all browsers currently connected. So we're synchronizing the view model.
How is the server involved?
So the server in this case literally just has SignalR. There's no server code that I've had to write to enable this. So one of the features that's a precursor to this that we're talking about adding for the next version of SignalR is the idea of classless hubs. Because as you saw in my move shape demo, the only code I wrote on the server side was relay. All I did was take some stuff from the client and then send it to all the other clients. Why do you even have to write that code? We could just do that for you on the fly, with the appropriate security and that type of stuff as well. So this would take advantage of that and just sort of layers on this idea of view model updates on top of that. So these are some of the crazy ideas we're talking about being able to add now that we have a real-time connection in the browser. Without something like SignalR, this just isn't really possible.
That's pretty cool.
That is pretty cool. So that's SignalR.
All right. You talk. You end. I'm falling apart.
Yeah, you fall apart. So we had a great look at SignalR there. We're going to come back after a short break and look at Azure, I think. Fantastic. So a few minutes and we'll be right back.